Git visualized to the metal. Episode 2. Narration. Last episode, we ran ls on .git/objects. We saw 2 folders and 1 strange name. Last time we used 2e as a placeholder. In our real repo, that strange name is 3b. The principle is the same. Today we explain how Git chose it. By the end of this episode, every character in that folder name will make sense. Not because we memorized it, because we will see how Git made it. 3 things we need. 1. SHA-1, the algorithm that named the folder. 2. Blobs, what Git stores inside. 3. Why Git split the name across a folder and a file. Start with the name. Where does 3b come from? Git can tell us directly. 3 stops ahead, SHA-1, blobs, and the 2-character split. Next, we ask Git for the name itself. SHA-1, the naming algorithm. How Git turns content into a 40-character fingerprint. Where did the name 3b come from? Not randomly. Git used an algorithm. Let's see it run. Git #object on hello.txt. Out comes a 40-character hexadecimal string, 3b18, and so on. A SHA-1 hash, the file's fingerprint, property 1. Same content, same hash. 2 files with identical bytes produce 3b18 again. Git uses this to deduplicate. 1 hash, 1 stored object. Property 2. 1 character changes everything. Add a single exclamation mark. Run #object. You get a 0423. Not similar, not close. Different. An empty file gives E69DE. This exact hash exists on every Git installation on Earth. Empty content has 1 universal name. We have a name, but where is the content? Inside the folder. Next, recap. 1 names content deterministically. Same bytes, same hash. 1 bit changed, totally new hash. Segment 3, Blobs, the storage format. We have the name, 3b18, 40 characters. Now let's find the content. It is sitting in a folder on disk. We just need to open it. Open the folder named 3b. Inside, 1 file. Its name is the remaining 38 characters of the hash. This file is the blob. Git cat -file, -p, then the hash. The letter P stands for pretty print. Git decompresses the blob and shows us the content. Hello world, the exact bytes we wrote in episode 1. But here's something interesting. If we cat the raw file directly, bypassing Git, we get garbage. The blob on disk is not plain text. Git compresses it with zlib. The cat file command decompresses on the fly. What is this thing called? Git cat file -t for type. The answer, blob, short for binary large object. The first of Git's 4 object types. We will meet the others later in the series. Here is what really happens when you stage a file. The content goes into Git's object database as a blob. The blob's name is the hash of the content. Content addressed storage. You ask Git for content by giving it a fingerprint. We have a blob, but why did Git split the name? 2 characters as a folder, 38 as the file. Why not just store it flat? Next segment, the file system answer. Recap. A blob is zlib compressed content stored by hash. Cat file pretty prints it back to plain text. Segment 4. Why 2 characters? Why Git splits the hash the way it does? Why did Git split the hash? 2 characters as a folder, 38 as a file. The answer is not about Git. It is about the file system underneath. Imagine every object dropped into 1 flat folder. A small project might have 100,000 objects. The Linux kernel has millions, all in 1 directory. Most file systems were not designed for 1 folder holding 1,000,000 files. Listing gets slow. Opening files gets slow. Even on modern hardware, it hurts. Git uses the first 2 hex characters as a folder name. 2 hex characters means 256 combinations. 1,000,000 objects spread across 256 folders is about 4,000 each. Manageable. The math is simple. 1,000,000 objects divided across 256 folders. About 4,000 per folder. Fast to list. Fast to open. The file system stays happy. Blobs hold content, but blobs do not know file names. So how does Git remember which blob is hello.txt? Next segment. Recap. Git splits hashes to spread objects across 256 folders, keeping the file system fast even with millions of objects. Quick recap. Episode 2. 3 things we now understand about how Git stores your files. 1. SHA-1 gives every piece of content a unique 40-character name. 2. Blobs are the objects that hold the actual bytes. 3. The 2-character folder split keeps the file system fast. But there is a problem. A blob is just content, just bytes. It does not know its file name. So how does Git remember that 3b is hello.txt? Episode 3. Trees, the object type that maps file names to blobs, the piece that turns a content database into a real file system. If this is the Git tutorial you wish you'd had, subscribe. One episode at a time, all the way to the metal. Recap. SHA-1 names content, blobs hold bytes, the split keeps it fast. Next episode, trees give those blobs names.